electronics techie. So in this video we are going to discuss about counters. So counters in digital electronics. So how it is going to be defined is, so a counter is a sequential circuit that counts the number of input pulses. So means what the counter is doing is it is one of the sequential circuit. So we all know about the sequential circuit. So it depends always depends on clock. Whereas in the sequential circuits and latches are also a sequential circuit, so you can't define it by clock itself. So whereas the latches are the level triggered and plugs are the edge triggered. So I think you all know about that. So here our topic is about a counter. So a counter is a sequential circuit. So what it done means it counts the number of input pulses. So whatever the pulses it will be like this. So how many input pulses you are going to give, it will be simply count like that. So as usual clock pulses. So input pulses is nothing but our clock pulses. So it counts the values in flip-flop. So what are the values? 1, 2, 3, 4 like that. It will count the values. The main purpose of the counter is to count the values in the flip-flops. So how many types of counters? There are the two types of counters. What are those? Asynchronous counter and synchronous counter. So what is asynchronous counter? We are another name of the asynchronous counter is like ripple counter. So why you make it as a ripple counter means, so you can in asynchronous flip-flop what you are going to give, so you are giving output as clock to the another flip-flop. So it is one flip-flop, it is another flip-flop. So what you are going to do means, so you are giving the output to the another flip-flop clock as a input. So that's why it also called as a ripple counter. So triggered by output of the previous flip-flop. So how it is going to trigger? So second flip-flop is going to be activated by the flip-flop of the means previous output. So first flip-flop output means previous output of the flip-flop is going to be assigned to the next flip-flop. According to that, this flip-flop is going to be work. That is the meaning of this statement. So second statement what it says, simply but slower due to the ripple delay. So the design of this asynchronous counter is fine, very simple like that, but there is a delay. So why it is going to be delay? After completion of this flip-flop working, then it produces the output. So that output is going to be input to the second one. Again, these output is going to input to the third one. So like that, there is a delay. Until these output is going to be come, this flip-flop is going to be wait. Means there is some delay according in this inside this process. So that's why there is some slower, and there is a less chances to be more delay in this asynchronous counter. So next one is a synchronous counter. So all flip-flop share a common clock. So in asynchronous flip-flop, what is going to be done means a common clock is going to be shared for every flip-flop. So this is the first one and second one. Whatever the sound, the same clock will be applicable for the all the flip-flops. So that is the advantage here. So that by that there is a fast, means there is no delay to stop by the second flip-flop, means there is no delay of getting output from one flip-flop to another flip-flop. There is nothing delay here. So that's why it becomes faster when compared to the asynchronous counter. So no ripple delay. So there is a no output is forwarded to second flip-flop. So that's why there is no ripple delay here. So this is some of the types. So common types of counter inside these asynchronous and synchronous counters. So there are some types. For the we can say binary counter, up counter, down counter, and up or down counter, and decade counter. Decade, you all know about that. 10 years we say the decade. So that's why we call it as mod 10 counter. So ring counter and Johnson counter. So these are the some of the types. In upcoming videos, we are briefly discuss about these counters, and we are going to discuss these counters as well as this Verilog code and design and simulation values also. So if you want other than these any counters, you can simply comment on it. So if you want to know any other than these counters, so I can make separate videos on them. But for my perceptions, I want to do code for all these counters what I have written here. So for that purpose, this is a complete overview about the counters. So before going into the counters and counter design and Verilog, so we have to know from starting point. That's why this video is going to be done by me. So I think it will be very useful for you. So applications are the counters. So where in real time where we are going to use these counters means, so digital clocks, we all know about the clocks. So in clocks we have the numbers counter, means from we have seconds, second 1 2 3 4 5 4 seconds and up to 60 seconds like that. So there is a counting process here. So every second it is going to be counting, and after that it will be going to update. So in digital clocks we are going to use this counters. Frequency dividers, we already discussed the frequency divider topic in our video. So if you don't want to go through that, so by using these counters only we are going to discuss about the frequency dividers. So event counters, so these are the some of the application timers and memory addressing. In these applications we are going to use these counters. So what is the difference between the asynchronous counter and synchronous counter. There is useful to know about these differences also. So clock. So what I already discussed about the clock. So different from each flip-flop. So here the clock is not same for all flip-flops. I already said that the output of the first flip-flop is going to clock for the second in flip-flop, and second flip-flop output is going to input to the third flip-flop. So there is a no common clock. So different for each flip-flop. There is a difference between the clock for every flip-flop. So common for, so coming to the synchronous, common for all flip-flops. So whatever the clock we have, so it will be common for all the flip-flops. We can observe here. So speed. So in asynchronous, there is some delay while passing the output to second flip-flop. So that's why there is some delay. So the speed is very slow. So and compared to the asynchronous counter, the synchronous counter is a little bit fast because there is common clock. There is no such delay to pass. So design. Coming to the design of how the architecture. So asynchronous is going to be very simple. So whereas the synchronous design is complexity is there. So delay. So in asynchronous, we all know about that. There is a pass of output to the second flip-flop. That's why the delay will be high. Whereas synchronous, the delay will be low. So these are the some of the small differences we have to note down. So it is very important for everyone. So coming to the summary. So what we are going to discuss in this complete video is like counters of sequential circuits. Uses for counting pulses. So we all know about the counters are there are two types of circuits, combinational and sequential. So from there, the counters are the sequential circuits. So we are going to use this for counting the pulses. So what are the pulses? Clock pulses. We are going to count that one. So another topic we are going to discuss what you are already discussed in this video is what are the counters. It will be classified into two types. One is asynchronous and second one is a synchronous. So used in where you are going to use timers, clocks, digital systems, you are going to use this counter in this particular applications. So thanks for watching. I think this video is going to be useful for you, and thanks for supporting, and then bye.